All right. So what we're going to do is go over what each part means of the function. We're only dealing with sine and cosine as of right now. So when we're talking about sine and cosine, you have your A, which stands for the absolute value of your A is your amplitude. Then you have your B, and your B is used to determine your period. Okay? Remember, period is before it repeats. How long does it take for your cycle to repeat? Okay? Remember, he went before it repeats. Before it repeats. Okay, that's what he was trying to get you to see, is that it's the repeating. All right? He also mentioned that if your A is negative, that means it's going to be what? It's going to be flipped. It's going to be reflected. Okay? If A is negative. Okay? If A is negative, it's going to be reflected. So if it's a positive 1, it's going to become a negative 1. If it's a negative 2, it's going to become a positive 2. Your values are going to be reflected. Okay? Next, he talked about the horizontal shift, aka your phase shift. That's why he kept writing PS, because it's called a phase shift. You're taking your phases. Huh? No, it's called a phase shift because it's broken into your periods. You're taking your period and you're shifting it. All right? Your phase shift is your horizontal shift. You're going left and right. In the function, if it says plus, that means you're moving to the left.
Is it because everything that's inside of the
Exactly. Exactly. Like we learned with transformations, everything inside of the parentheses with x means we do the opposite of what's there. Okay? Yes, they are. If it has a negative in the function, that means you're actually moving to the right. Okay? And he did that without telling you when he wrote down his phase shift as a negative pi over 2. All right? Next we have K, which is our vertical shift. With K as your vertical shift, if it says plus, you do what you think it's supposed to. You're going to go up. When it says minus, you're going to go down. All right, so those are the key things in your function. So now let's identify what we have. Here we have A is a 3. If B is not there, what's the value? 1. Okay? And then therefore my phase shift is, it's a positive, so it's actually a negative. So my phase shift is actually a negative pi over 2.
Is that an H?
Yes, because it stands for horizontal shift. I don't like writing PS.
Why did you make that pi over 2?
Okay, we just kind of went over that, but I'll go over it again. For horizontal transformations, when it's in the inside, the original function is x minus a number. Okay, it's x minus a positive number. But if it becomes x plus a number, that means I had to take a negative and put it with a minus with a negative. And a negative times a negative is a positive. So it's going to appear as a positive, but it's actually a negative value. Okay, it's going to appear as a positive, but it's actually a negative value. Because the only way I can move to the left is if I do what to my values? Subtract, right? The only way I can move to the left is if I actually subtract my values. All right? And then K. My K is my vertical shift, and that is negative 1. All right? So on your worksheet, it wants you to describe what's happening. So my amplitude is 3. My amplitude is saying from the middle of my function to the height of my function, or from the middle of my function to the minimum of my function, there's only 3 spaces separating us. There's only 3 units in between us. Okay? My period, I determine my period by doing 2 pi divided by b. And what's my b value? So my period is, my horizontal shift tells me what direction, left or right, I'm going. Am I moving left or right in any direction?
Yeah. Left.
Exactly. I'm going to go left how much? Pi over 2. Okay, that negative pi over 2 just lets me know that I have to subtract that value. I am subtracting. All right, do I have a shift, a vertical shift? I'm going to do what? I'm going to go down 1. So now I've identified everything that matters. Okay, he talked about 5 key points. Your 5 key points that you're using is actually in your parent function notebook that we made. And then your 5 key functions, in case you have yet to memorize them, would be 0, pi over 2, pi, it's 3 pi over 2, sorry, 3 pi over 2 and 2 pi. The values we're on sine. Sine starts at 0, then it goes to 1, then it goes to 0, then it goes to -1, and it comes back up at 0. Those are my 5 initial points that are in my parent function notebook, correct? Do we understand where these came from? Okay, so if I was to plot this, it would give me my parent function. Well, things are changing to this parent function, right? These values aren't going to stay the same. So before I graph, I prefer to make a table of things that change. So therefore, I'm going to have a table with my 5 new values, and then I can plot. Okay? Okay, so when I look at this, is anything happening to my x values? Is it shrinking or stretching? My period's staying the same. 2 pi is what my standard period is, right? So is anything happening to x based on my period? No, I'm not stretching and I'm not shrinking, okay? Now, am I moving though? Yes. So that means to each x value I'm going to need to subtract, right? I'm going to need to subtract pi over, and I wrote that backwards. So I'm going to do x minus pi over 2. So with every value, I'm going to do x minus pi over 2. Now, key thing here, guys, when you put this in the calculator, if you're going to do it with a calculator, you need to be mindful of the pi's. You do not need to put pi in the calculator. You just want to focus on the numbers. Okay? So 0 minus pi over 2. If I was to put that in the calculator, I would write 0 minus 1 half. So I would put 0 minus a half in the calculator. And what is that? -1 half. So my new value is at negative pi over 2. All right. So then next here, at pi over 2, if I'm doing 1 half minus 1 half, what is that going to become?
1 half minus 1 half
It's going to be 0, right? If I have 50 cents and I spend 50 cents, how much do I have left? 0. All right, what's 1 pi minus half of a pi? You had a whole pie, you ate half of it. What's left? Half of a pie. I wanted pi over 2. Okay, if I have 3 pi over 2, which means I have 1.5 of a pi, and I take away 0.5 of that pi, what am I left with? I'm just left with 1. Okay? So mathematically, if I have 3 halves of a pie, and I subtract half of a pie, what am I left with? Uno. Yes. You said come again. I came again. I told you. All right, here we go. 2 pi. I need to subtract a half from 2 pi. What am I left with? 1 and a half. And we write that as a fraction as 3 pi over. My x values are done. Now I'm on to my y values. With my y values, I know that they're going to be what? Instead of my function being at 1 and -1, it's going to have to be what? It's going to expand to 3 and -3. And then after I expand, I'm going to have to do what? Shift down 1. So my final location will be at 2 and -4, right? All right, so to my y values, I'm going to have to do 3 times y. And then once I do 3 times y, I'm going to have to do what? Subtract 1. So to every y value, I'm going to do 3 times 1 and then subtract 1. So what's 3 times 0? 0. Minus 1? -1. 1 times 3
3.
minus 1.
2. -1.
Okay, again at 0 it's going to give me -1. Alright, I have -1 times 3, which is?
-3.
And -3 minus 1 is?
-4.
Good job. And then my final point is? -1. Is my new table completed?
Yes.
Can I just plot those points now?
Yes.
Alright, so I'm going to go to -pi/2, and I'm going to go to -1. I'm going to go to 0, and I'm going to go to +2. I'm going to go to pi/2, and I'm going to go to -1. I'm going to go to pi, and I'm going to go down to -4. And I'm going to go to 3pi/2, and I'm going to go to -1. And there's my transformation. Like he said, this is a function that can continually repeat, right? It's going to technically go on forever. So if we want to be technical, we could draw arrows onto it because that demonstrates that the function is going to continue. And if it continues, therefore my domain is what? Beautiful. And my range is what? -4 to +2. And what kind of? I'm going to have brackets because they are contained in between those two values. And at those two values, I have a value, right?
Miss John,
Yes.
I kind of get it, but I'm kind of skeptical on how you created both of them graphs. Like, it's just.
You didn't make. You said a lot of words.
Yeah, exactly. That's how I feel about it.
Yeah, I'm not getting this.
Yeah, I get it. I can go along with you, but like, just like when I look back at how you did that, I don't get it.
Okay. All right. So our first step was we just looked in our parent function, notebook, and we wrote down our 5 key values. Right. That was the first thing we did, and then we already had described what should happen to each value. We know that amplitude affects y, period affects our x, shift affects our x, and vertical shift affects our y. So we take these points and we're doing them variable by variable. So we're going to do what affects x first. So when we look at our period, did our period change?
So you finish everything that go is first?
Mm-hmm. Did anything happen to our period? No, our period's going to stay the same. So we didn't do anything here because we didn't have to change our period.
How did you get that?
How did we get our period?
Your exes, like, how did you?
It came from our parent function notebook. Take out your notebook. I said it 3 times. Take out your notebook.
Always be the same or it will change?
Huh? No, your period can change. This was just an example where our period didn't change. When you watch that video with that man, all but one example didn't change period. Okay? So your notebook, that's why I told y'all you need to learn these values. That's why we made it. And I said, guys, study this notebook because you need to know these values.
So if it didn't have that 2 pi, it'd be a different value. Like different.
If our 2 pi was changed, then our first step, our x's would have changed twice. Instead of just only having to change once, our x values would have had to change twice. When we get to our next example, our x values are going to change 2 times. But I have to be able to get to the next one in order to show you this. All right? So we're going to go on to the next problem so we can see how our x values are going to change. All right, so now we are still dealing with, we're now dealing with what? What function? Cosine. We're dealing with cosine. It says 2 minus 2 cosine pi/3 times x plus 1. Correct? The only thing that this problem did wrong, well, it's not wrong, but could confuse you, is that they put your vertical shift in the front. Okay? It's still your vertical shift. If that bothers you, then you just rewrite it as
So unless it's connected to like cosine, then it's a vertical or it's a vertical.
So it's a
Yes.
vertical shift?
Mm-hmm.
And as long as
So
it's
they just
outside
put it
of
in the
parentheses.
Okay? They put it in the front because a lot of mathematicians do not like to lead a problem with a negative. Okay? If it's already a positive, if they could avoid leading a problem with a negative, they will put a positive in front. So instead of putting the positive at the end, they brought the positive to the front so that they wouldn't have to lead their function with a negative. And the reason being is that before calculators became so sophisticated, you had to be very conscious about putting negatives into calculators because it can make a serious error in your calculations. So that's why they try to avoid leading with the negative. Cool? All right, so what you just need to understand is that this is still my vertical shift. It was just placed in the front. All right, so we're going to talk about amplitude. From this problem, well, first off, I'm sorry, I wanted to mention something. What do we have that we didn't have before? My A is what?
Negative.
My A is negative. So my shape is automatically going to reflect. So instead of looking like this,
It's gonna be up top.
I'm actually going to look like that, right? I'm going to be reflected. So instead of this being at a positive 1, it's going to be at a negative 1. So when we start writing our table out, we have to keep that in mind when we first write our values out. Okay? So our amplitude is what?
-2.
It's a positive 2. Amplitude is the absolute value of it. Absolute value does not like what? Negatives. When you put absolute values around something, it makes it turn out to be positive. The reason why... I'm about to tell you. The reason why your amplitude is positive is because you're talking about distance. Okay? Amplitude is saying how far are you from something. And when you're talking about distance, you don't talk in the negative sense. You don't say, I walked backwards home, so I walked a negative 2 miles. No, just because you walk backwards, you still walk 2 miles home. Okay? Distance doesn't have negative values.
No negative.
For amplitude, there's no negative.
So there will never be a negative for amplitude.
No, the negative just tells you that your shape of your function has been flipped it, okay? All right, period. So my period is determined by 2 pi divided by my b value. What is my b value here now? Pi over 3. So my period is 2 pi divided by pi over 3. And that equals 6. Okay, 2 pi divided by pi over 3 equals 6. If you can't do that in your head, there is a calculator. You go to the calculator. You hit Control Divide. You type in 2 pi divided by pi over 3. And it tells you what?
6.
My period is 6. If you do not have a calculator at home, you need to remember how to multiply and divide fractions. You are seniors in high school and a couple of juniors. But you need to know that if I have 2 pi and I'm dividing by pi over 3, the rule for dividing fractions is that I keep, change, flip. So 2 pi over 1 times 3 over pi. What happens to my pi's?
Cross it out.
They cancel out. And 2 times 3 is 6. You need to remember how to multiply and divide fractions, guys. Okay? So, regardless of whether you have a calculator or not, you should be able to do that. My horizontal shift is determined by my h. What is my h?
1.
What kind of 1?
Positive.
So that means it's actually, I'm going to end up subtracting 1. So that means my function is moving to the left 1. What is my vertical shift?
It's gonna be 2.
It's going to be up 2. Okay, so we're still starting off with those same x values. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, however, my y values are changed. My y values have been reflected because of that negative. So instead of starting off with a positive 1, it's going to be a negative 1. And this is because, again, of that negative in front of my a value. So this is negative 1. This is still going to be 0. This is going to be positive 1. This is still 0. And this is going to be negative 1. And again, that's because of the negative in front of my a value. The negative in front of my a value is causing this to happen. All right, so now I have my table and I have things to deal with my table. Now my period has changed. I'm no longer going from 0 to 2 pi. I'm now going from 0 to 6. And then not only am I doing that, then I'm going to have to shift each one of those to the left by 1, which means in order to do that, I have to subtract 1. Okay, in order to go to the left, that means I have to subtract 1. Think about it logically. If I want to move backwards, I subtract. If I want to move forward, I'm going to add. Okay, so we're going to create a table of this. Okay, so with my x values, they're now going from 0 to 6. What's the middle of that?
1, 2, 3, 4, 5, 6.
What's the middle of 0 and 6? What's
3.
3? What's in between 0 and 3?
1.5.
What's in between 3 and 6?
4.5.
Yeah.
Okay?
And this number, you know, top of here.
Huh?
I said that's just number you're gonna know off top of your head.
Yeah, because 3 plus 6 is 9, and half of 9 is 4.5. And 0 plus 3 is 3, and half of 3 is 1.5. Okay? And that's because my period has changed. So my period is now no longer from 0 to 2 pi, it's from 0 to 6. So I had to acknowledge the fact that my period changed. Now that I've acknowledged the fact that my period changed, to every one of these numbers, what do I need to do? Subtract 1, because I need to move it to the left. So 0 minus 1 is going to give me what? Negative 1. So instead of a 0, this is a negative 1. 1.5 minus 1 is? 3 minus 1 is? 4.5 minus 1 is? No.
Oh, it isn't?
6 minus 1 is?
5.
Okay?
I'm sorry, Mr. Jones, I was rudely interrupted. You should,
We subtracted 1 from each number.
from negative 1, right?
Yeah. Because you have to go left one. See, left one.
From the X's.
From the x's, we haven't did anything to our y's.
Oh, yeah.
Alright? Now, to our y's, what are we doing?
Plus 2.
And we are doing what? Are we being amplified?
Yes, by 2.
Okay, so to my y's, I need to multiply by 2, and then,
Add.
so to every y, I'm going to multiply by 2, and then I'm going to add 2. So my ultimate response is to multiply by, and then add 2. So what's negative 1 times 2?
Negative 2.
Plus 2 is?
0.
Beautiful. What's 0 times 2? 0. Plus 2 is? 2. What's 1 times 2? 2. Plus 2 is? 4. What was my hit? 0? Is that what we're on?
Yeah.
Yep.
And what do I get?
2.
2.
And then last but not least, negative 1.
It's 2.
So now I have my new point. So at negative 1, I'm going to go to 0. At 0.5, I'm going to go to
2.
At 2, I'm going to go to
4.
At 3.5, I'm going to go to
2.
And at 5, I'm going to go to
0.
That's the ugliest sine cosine graph ever. But you get it. Oh, that's why it's ugly. Because it's wrong.
0.5, I was going to say that.
No, that's not where it's wrong.
Wait a minute, child.
It goes like that.
So that- look at that gap right there.
Huh?
Look at that gap right there.
I'm reading it
That's the
wrong.
decimal
Oh,
point.
This is counting by half. 1 half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5.
Yeah, but I was saying
Five. Okay?
Why did the arrows go up?
The arrows go up because what is my minimum value? 0. I can't go past
Oh.
0, and I can't go higher than 4. So my domain is all real numbers, and my range is restricted to 0 and 4.
So we can put all numbers instead of negative and that.
Yeah, I'm okay with that. I just didn't feel like drawing the infinity symbol.
What is all real numbers?
That means from negative infinity to positive infinity.
So instead of writing negative, then I'll just put real numbers.
The brackets.
True.
Yes. Brackets means that this is where I stop at, and that I have a value there. It's a closed circle there. Parentheses, if there's a number, means that this is where I stop at, but there's an open circle there, which means there's no value that exists there. But we don't have any holes in our graph, so therefore it will be. Okay? Alright, let's get another one in. Cosine. Yes. Marilla. It's completion though, not accuracy. Alright, so what's my amp?
1.
1. Because is there an A in front?
So do we have to distribute the 4, or is the 4 our vertical?
The 4 is my B.
Period, right?
It's to help find my period. How is it 1? My amp is 1 because there's no value in front of here. So the only number that can be invisible when you're multiplying is 1. The number that's invisible when you're adding is what? 0?
No, it's about the per. The PER. Power 2.
Oh, I was like, I thought you were saying 2 was invisible. I was like, no. Alright, so I'm going to put 2 pi over 4. And that gives me that my period is pi over 2. I'm sorry.
Yeah.
I can multiply and reduce, guys. I promise.
Trying to get my entity dealt me, man.
Alright, pi over 2. Okay? Remember, to find period, the rule on the other side is 2 pi divided by b. So I take 2 pi and I divide it by whatever my b value is. My b value is 4, so 2 pi divided by 4 is pi over 2.
And your H shift's gonna be positive 5, positive 6.
So that means I'm going what direction?
Right.
Alright? And what about vertical shift?
The vertical shift goes 1.
Oh,
0.
0.
Listen to me.
Okay? Vertical shift is going to be 0 because that's my invisible number when I'm adding and subtracting. Okay?
Get your X and Y.
Alright, so we're going to write out our x and y. So what's our standard, our parent function?
0, power over 2, pi, 3 power over 2, and 2 pi.
Alright, it's cosine. So do I start with the 0 or do I start with the 1?
1.
Start with the 1.
Because there's no negative or positive.
Okay? So those are cosine functions.
Wait, what are you starting?
Huh?
Because you didn't have to flip it. It went
Oh, yeah,
it
it's
went negative.
Alright, so let's start with our x's. What are we going to do to our x? First thing first, our period has changed, right? We went from being 2 pi, and now we're going to compress it to pi over 2, so we're making it shorter, right?
Yeah.
So our period is shorter. So we're making our period shorter. So we're going now from 0 to 2 pi to 0 to pi over 2. So we need to find the halfway mark between $0 and 50 cents.
Power 4.
Pi over 4.
Yeah. Quarter.
It's a quarter of a pi. Okay? Now what's between a quarter and 0?
Power 8.
Pi over 8.
I wouldn't thought about that.
And then
I don't know.
3 power over 2.
No. I don't know.
what's 1/8
Dang.
plus 2/8?
3 over
3 pi.
3/8.
Yeah.
You take these two values and you would add them together. So I would put 1/8 plus 1/4 in the calculator and it would tell me it's 3 pi over 8. Okay? So now we know where we are based on our period. Now we know our period, but we're not done because what do we have left to do with that period?
Right.
We're going to go right, so we have to do what with that 5 pi over 6? Add it. Now, I know you guys may not be the strongest adders with fractions. No offense, hopefully taken.
So you do 1 plus 5 power?
So what you need to be conscious of when you're doing the calculator, 0 is easy. What's 0 plus 5 pi over 6? Okay? So this is going to become 5 pi over 6. Piece of pie, right? Now, 1/8 and 5 over 6 you may not know. So you're going to go to the calculator and you put in 1/8 plus 5 over 6. And it tells you what it's going to become. What is that value? 23 pi over 24.
Sound like a ghetto, man.
That's like a 23.
It is.
Oh.
All right, so now I have 1/4, and then I'll continue that. We will finish this tomorrow. If you want to go ahead and finish, my hint for you is that each one of these marks is a sixth of a mark. We need to take sixes and turn it into 24. So how many pieces would we have to split that mark into? Into 4 pieces.
That little bitty square?
Into 4 pieces.
What the heck?
I believe in you.
Give us coordination.